It's crazy to say this, but I've been in Arkansas now for 9 years, almost 10 years, and I serve our fruit and vegetable growers across the state. My background is in horticulture and soil science, so I did my PhD looking at practices that we can implement to improve soil health, specifically in strawberry production systems. And so a lot of what I still work on kind of follows that same trend of looking at how do we improve sustainability of berry systems primarily. But I do a little bit of work in veggies, and we do regular trials every year looking at different cover crops. And so I'm excited to be here today to talk a little bit specifically on cover crops. But if you ever have berry questions, and I love the little baby in the back with the strawberry hat, please don't hesitate to reach out. So, you know, I'm sure this is not something new to any of you, but I think it's important to start off and talk about what is a cover crop. So a cover crop, in my mind, is a crop that we are growing because of the impact that crop is going to have on the soil or on the environment in our farm. So it is not something that we are planting because we want to necessarily sell it and make money, though sometimes certain cover crops, there might be some potential for that. But generally we're growing it because it's going to have some impact on soil and hopefully promoting soil health or suppressing weeds or adding nitrogen to the soil. And so that is the reason why we plant a cover crop. And of course, there are kind of 3 large classes of cover crops. And I'm not going to get into this too much because I don't really want to trail into the next speaker's domain. But I want to kind of start here just because in my presentation, I want to talk about, you know, what are the benefits of different cover crops? What do we know scientifically can cover crops do to the soil and particularly in an organic system? And so I think it's important to highlight that there's these 3 groups because these 3 groups do have different impacts. So generally we break up cover crops into either grasses, leguminous cover crops, or sort of our brassicas type covers like mustards. And the reason why we usually plant grasses is because these things have really fibrous root systems. They produce a ton of biomass. And so they are the ones that we're going to plant primarily because they're going to have an impact on increasing soil organic matter because they produce so much biomass. Our leguminous cover crops we plant because they are nitrogen fixers. So they have a really interesting relationship with rhizobacteria that live in their roots that actually can take atmospheric nitrogen and convert it into a biological form of nitrogen that can then be cycled and taken up by plants. So they're basically little nitrogen factories. And then our brassicas and other similar cover crops we plant because they generally have a nice impact on suppressing diseases. But one thing I always like to emphasize to people when they're thinking about cover crops is really, you know, we are probably going to want some of those benefits from each one of those groups. And so very often we're not going to just plant one, we're going to plant several and hope that we can try and get a little bit of organic matter addition to the soil, get some nitrogen, and maybe also have some disease suppression. And of course that disease suppression is not only exclusive to brassicas, there can be some disease suppression characteristics present in some of our grasses as well, and we'll talk a little bit about that. And so we're going to choose some of these different cover crops. But before I get into talking about, you know, specifically what we know these different cover crops can do to the soil, I think it's important also to mention that, you know, primarily what we're interested in using these because we're not planting them to make money, we're planting them because they're going to impact soil, is this idea of soil health. And you know, there are tons of different definitions of what soil health is, and some of them can get really academic and, you know, very heady and hard to understand. But, you know, the reason why we're doing this is not for an immediate return always. Sometimes the reason why we're doing this is for a long-term commitment to that ground and changing the health of that ground so that that ground continues to be productive over a long term and that we're really looking at this as a long-term relationship and a long-term investment. And I think that's important to emphasize, particularly in the South, because, you know, when we start talking about building organic matter, we live in an environment where there's a lot of rainfall and there's really warm temperatures. And those are both 2 things that help organic matter burn off over time. And so the process of building soil health and building organic matter is not an overnight thing, right? We're really going to be committed to it in the long term. And that's important for this idea of soil health because we're committed over the long term to maintaining that healthy environment through the consideration of the production practices we implement. I do want to briefly mention that, you know, when we're talking about cover crops, there are going to be some specific requirements that we need to keep in mind if we're talking about an organic system. And there's a lot of words on this slide, so if you want to take a picture, please feel free. But there's two kind of things I think to keep in mind when you're thinking about using cover crops specifically in an organic system. And one of those is that organic certification requires that you have a plan in place that is going to help promote the long-term health of that soil. And so cover crops is going to be a thing that it fits very well into that requirement of helping with crop rotation, of adding organic matter back into the soil, and the like. The second thing to keep in mind is the specific rules and requirements for then implementing cover crops in that organic system. And so this is going to start going into thinking about where am I going to source potentially cover crop seed that is organic certified. And if I'm not able to find seed that is organic certified, working with your certifier to make sure that you are able to document that so that you can get exemptions and find other seed. And this is something that's constantly evolving. A few years ago during COVID, there was actually the supply of cover crop seed in a lot of places went through kind of a lull, and so the availability of cover crop seed in general of certain species went down, and so it's something you're just going to need to be in touch with your certifier about to figure out if you can find organic seed or that seed that has been untreated, and just being aware of that availability. And of course, with organic certification, GMOs are never going to be allowed, but most GMO, like soybeans, would be an example of a cover crop that you might plant that could be GMO, but that seed would be very expensive, so you probably would avoid it anyway. All right. So for my presentation, I want to really kind of dig into these different services that cover crops can provide for us when we start integrating them into our production systems. And I'm going to kind of take it from a holistic perspective, but I wanted to start with this slide and just kind of show you, these are some of the things that we're going to talk about. And I think it's nice to frame it from that there are some benefits that we kind of see above ground, there are some benefits we may see at the soil surface, and then there are some benefits that we may not see as clearly that are happening underground below the surface. So, of course, when we plant a cover crop, while that cover crop is growing, it can be a habitat for beneficial insects. While it is growing, it can also help suppress weeds, and then when we mow it and leave it on the soil surface, it may also continue that service. While it's growing and on the soil surface, it can, of course, protect the soil from erosion. Those roots of the cover crop, as they're growing down into the soil, can capture nutrients that are held there and prevent those nutrients from being lost through leaching. As we add that organic matter back into the soil, it can increase soil organic matter. Cover crops can increase soil nitrogen. Because we are planting something when maybe that ground would otherwise sit fallow and just be bare, it's also important to think about that those plants are there and are providing an environment for different microorganisms to live in. So our mycorrhizal fungi are an example of a beneficial microorganism that are present in the soil that have to have a plant host in order to reproduce and expand. And so planting a cover crop can also serve that role. If we're strategic about which types of cover crops we plant, we can also suppress nematodes. So they can also have an impact on suppressing maybe negative microbial activity in the soil that might be detrimental to our crops. And the other thing I always like to have people think about is that some of our cover crops have very different rooting patterns than some of our cash crops. And in particular, some of these grasses can be very deep rooting, and they can actually access nutrients that are held in deeper layers of the soil and are essentially mining those nutrients, bringing them up into the biomass that's above ground, and can help with some of that nutrient cycling potentially. But I'm going to kind of jump in and give you some highlights of research that is out there that we know of how cover crops can impact soil health. And then at the end, I'm going to wrap up and share some of just brief highlights of some of the research that we've done in Arkansas as far as which cover crop mixes we know can work well for certain systems and which types of cover crops or mixes I would recommend briefly. So this is a statistic that I find really concerning. 20 to 30 billion tons of soil is eroded due to water erosion, and 2 billion or more tons due to wind erosion worldwide each year. That's a lot of topsoil. And if we think about topsoil being really the primary place where we are producing our crops, and generally our topsoil is going to be higher in organic matter and in nutrients, we're really losing, a very valuable resource every year that is going to be really important for agriculture. And this is not something that's a resource that's renewable in our lifetimes. The top inches of our soil take a long time to develop. So it takes 500 to 1,000 years to form 1 inch of topsoil. So in my mind, our topsoil is not a renewable resource. It is, but not in our lifetimes. And so anything that we can do to protect that topsoil from being eroded due to wind or erosion or to wind or water is going to be really important. And of course, when we plant a cover crop, that cover crop is then providing that protection during a period when potentially otherwise that field might sit fallow. Cover crops, of course, can also help suppress weeds. And weed suppression can kind of occur from a cover crop 2 different ways. In the season in which the cover crop is growing and is active, and then in the following season, even after that cover crop is maybe mowed or rolled down, it can act as a physical barrier on the soil surface to suppress weeds as well. This is a picture here on the bottom of, we've done a lot of cover crop research looking at the mixture of pearl millet and cowpeas. This is a cover crop mix that I really recommend for the summer for a lot of different reasons. It works really well for strawberry systems. It's worked well for us for broccoli, planted into the fall. And so on this picture on the bottom, on the left-hand side, you can see a plot where we didn't plant a cover crop. On the right-hand side, you can see a plot where we mixed that cover crop. So it's 100 pounds of cowpea, 10 pounds of pearl millet. So you can see all the soil cover that you're getting from that cover crop on the right-hand side. Versus on the left-hand side, I don't know if you can see what's growing there, but does anyone recognize that plant? Anybody know what that is? Hopefully you don't recognize it because it's not on your farm, but I doubt it. Did anybody? I think I heard it. It's a pigweed. It's a pigweed, right? And that is a very aggressively growing weed problem, right? A single pigweed plant will produce millions of pigweed seeds. If you let one of them go to seed, you'll fight it for the next 50 years. And that was what is germinating. That, and actually Johnson grass, is what is germinating in that fallow plot next to it. Whereas if you look in that cover crop plot, you really can't see anything coming up, right? That cover crop is doing a good job of suppressing that and providing that soil cover. So that weed suppression can really be very successful in season in reducing that weed seed bank by not allowing those things to germinate and set seed. But then, of course, we can also terminate that cover crop and leave it on the soil surface. And I'll show you some more pictures of examples of when we've done that. And that can be a successful way to suppress weeds as well in season. And of course, cover crops can also reduce pest pressure. So this can happen also in several different ways. One way that I really like to think about using cover crops to reduce pest pressure is incorporating them during those fallow periods when you might not have something else planted as a way to diversify your crop rotation. So most of our cover crops are in different families than our potential cash crops are. So if we finish out with, I'm on a strawberry kick. I had strawberries all day yesterday, so I'm going to keep talking about strawberries. But if we finish our strawberry crop in May, and we're not going to plant our next strawberry crop until September, we got a nice window there in the middle of the summer where we can plant a cover crop that's going to be a non-host to potentially nematodes, and it's going to help diversify what is being planted in that field other than just going strawberry after strawberry after strawberry. So I think cover crops are great to reduce pest pressure in terms of integrating them so that you're switching up what crops are being planted. And also in doing that type of rotation, we can also switch, not only plant families, but what type of things might be planted and what hosts they may be to some of our nematode populations. So a lot of our grass cover crops, if you're strategic, and sometimes our leguminous cover crops for certain species, but definitely our mustards, tend to be either poor hosts, so they're not an ideal host, or a non-host, which means they really do not host certain nematode populations. And so if we are strategic in kind of planning those rotations and mixing in cover crops that are non-host, we can kind of help drive down some of those nematode populations over time. And one way that cover crops get used a lot to reduce pest pressure is by focusing on using those brassica cover crops. So thinking about using a mustard cover crop as a biological fumigant is a great opportunity to really use that cover crop biomass to drive down disease pressure. The way that this works is kind of interesting. So inside the leaves of our brassica family, so mustard being one of those, there's some interesting chemicals that are actually held inside the leaves of the mustard. And they're held inside separate cells. But when we go in and mow or chop up those leaves, those cells get broken up and those chemicals get combined, and the chemicals combine and create a new chemical that acts as a biological fumigant. So always think about this when you start munching on a mustard leaf and you get that like really pungent kind of thing. So the same thing can happen when you plant that mustard cover crop, go in and mow it. You start mixing those chemicals that are held in adjacent cells. You till it into the soil, and that releases that chemical into the soil that then acts as a biological fumigant. And that biological fumigant potentially can have impacts on reducing pest pressure in terms of disease, insects, nematodes, and in some cases even weed seeds. But again, the key to using mustard cover crops in that way is making sure that you grow a really strong stand so that you have a lot of leaves, coming in and mowing it so that you get that mixing of chemicals, and then immediately tilling that material into the soil so that that release of the chemical is happening in the soil. And this is something that, again, growers have had success with in strawberries and in other crops of growing a mustard cover crop just prior to their cash crop to kind of clean things up. You know, there's limits of how much that can go, but we've had growers even in South Arkansas who are conventional watermelon growers who have used this to get rid of some heavy disease pressure on sandy ground. The other thing I always like to remind people is just be strategic in thinking through what is the issue you're trying to solve, and then make sure that your cover crop is matching that issue that you're trying to solve. So if you know you have heavy nematode pressure and that's the thing that you want to target, figure out what's the specific nematode that you're having an issue with, because there's lots of different ones, and then figure out which cover crop is going to be a poor or a non-host for that so that you can start driving those populations down, because you do need to be strategic. For example, cowpea is a great summer leguminous cover crop. Generally is not resistant to nematodes, but the variety of iron clay cowpeas is resistant to root knot nematodes. And so if you can be kind of strategic there, you can maximize your benefit of planting that cover crop. Another thing I always like to mention to people is that cover crops can affect soil temperature. And so this is an example of a trial that we were doing where we left some cover crop residue on the soil surface down in Hope, Arkansas, and we were going to plant some watermelons into it in a kind of a no-till system. And it had turned really hot and dry out at our location. You can kind of see that the soil on the right-hand side that's bare is starting to get some cracks in it, so it's starting to get dry and hot. And this is the soil on the left-hand side that's under that cover crop residue. This was a cereal rye that we laid down. And so this was in late afternoon, and I went out and put some soil thermometers in the ground, and you can see that they're not really that far apart from each other. You know, they're maybe 10 inches apart from one another. But look at the difference in the soil temperature just from having that cover on the soil versus being bare soil. And this is where I always like to emphasize that, you know, plants don't get to go inside into the air conditioning in the afternoon, right? They get to just hang out in the hot all afternoon and all evening, and there's no respite from our hot conditions. And so if anything that we can do to try and create a microenvironment around our plants where there's potentially reduced stress can really help those plants do better when it gets hot in Arkansas. And we all know how hot it can get. And so to me, you know, that 6-degree temperature difference, you know, that's impacting soil moisture, that's impacting the environment that those plant roots are living in. However, the thing to keep in mind is I took this picture in June, right? In June, we don't want the soil temperature to be hotter, but in certain times of the year, we do want the soil temperature to be hotter when we're trying to get things established and growing in the spring. So I think it's good to keep in mind that cover crops can also have this impact earlier season, and sometimes it cannot be a benefit, right? If we have a soil cover crop residue on the soil surface in the spring and we're trying to establish a warm season crop, that warm season crop may be experiencing slightly cooler temperatures under that cover crop biomass that could actually delay it. And there's some research that was done in the southeast that found this, that in eggplant in particular, there was lower soil temperatures in a no-till eggplant system that resulted in delayed harvest and reduced yields when compared to a bare ground plot or a black plastic mulch plot. So this is where we got to figure out where these cover crops can fit within our system so that they're a benefit to our system, but maybe are not having any detrimental effects. And so keep that in mind. We have seen this, particularly in our watermelon research, where the soil temperatures stayed cooler and wetter early in the season, and that delayed how quickly those watermelon vines took off in a no-till system. Of course, cover crops can increase water infiltration and break up hard pans. Research has shown cover crops can increase water infiltration by 8 to 528%. And this, in particular, I like to think about because, we go through periods in Arkansas where we get no rain, and then all of a sudden we get all of the rain, right? And we would really like for that water to move down into the soil profile so that it's going to be held and captured. What we don't ever really want to see is that it's ponding and running off, right? Because when things start ponding and running off, they're also taking nutrients, they're taking our topsoil, potentially some organic matter with them. We would much rather that water really move down into the soil. And this is a picture of a soil cut that they took at a conference in North Carolina. It was a conference focused on cover crops, sponsored by SARE. And they grew these cover crops in these glass boxes. And you can just see that's a box that's 3 feet tall, and they planted a single corn plant in it, and you can just see those roots going all the way down to the bottom of that box. And so those roots are creating little micro channels all the way down into the soil where that water can then infiltrate down and go into the soil rather than having an open soil that's getting a crust on it that's causing water not to move down into it. And there's, of course, research that backs this up. In a no-till system on tomatoes, they found that in drought years, rye cover crop mulch had higher marketable tomato yields compared to plastic mulch, and they attributed it to better soil moisture conservation. And this was work that was done, I believe, in Alabama in a droughty year where they were able to show that, going back to what I showed you before, that temperature is staying cooler under that no-till system, and it's contributing to better soil moisture conservation. And this is one of my favorite pictures of this guy who, it's just him holding these different grass cover crops and the root biomass that is being produced below ground. And this is the thing that we don't see, right? We go out in the field and we see everything that's above ground, but we don't see the thing that's happening below ground. And there's a lot happening below ground, right? Look at how much biomass that above ground, it may be 2 feet, but it's really going almost double that below ground. And so when we talk about the creating the root channels and allowing water to move downward, but also those roots are doing the reverse, right? They are accessing water and nutrients really deep in the soil and then moving it up into the plant to create more plant biomass above ground. And then those nutrients wind up on the soil surface when we kill that cover crop. So that cover crop is doing that mining. And so thinking about the nutrient effects of cover crops on soil can be really important. And of course, the biggest thing that we usually look towards cover crops in terms of managing nutrients is the potential to create our own nitrogen. So planting a leguminous cover crop that's going to actually take nitrogen out of the atmosphere, convert it into plant or biological form that then can eventually become a plant available form. It's kind of really exciting that, if you have a time in your cropping season where you're not going to be doing a cash crop, is there something that you could plant out there that would start taking nitrogen and basically pumping it out of the atmosphere and then holding it in the roots, and then when you kill that cover crop, that nitrogen becomes slowly available to your next cash crop. That's really exciting that we can actually, farm nitrogen essentially on our farm and potentially create nitrogen for our next cash crops. And of course, the way that this happens is in this association of rhizobacteria that live inside of the roots of leguminous plants. And I always encourage people to just go out, if you have a soybean cover crop, a cowpea cover crop, or even a clover cover crop, pull up one of those plants after that plant has started to get pretty mature, especially if you do it when it's starting to flower. You'll really be able to probably see this. And on the roots, you'll be able to find the little nodules where the rhizobacteria are living. And one thing that I think is always fun to do is if you go and cut open those nodules and it turns red as soon as it hits the air, you know that those bacteria are active and actively converting nitrogen, because there's a chemical that reacts with air and it turns red. So it has a similar name to, when our blood turns red from reacting with oxygen. It has a similar name. And so that's a cool thing to just go and check. You can go and cut open those nodules and see if my leguminous cover crop is actively fixing nitrogen. So I always like to go through exactly how does this work, just because I think it's important for people to understand that there's a little bit of a process of taking nitrogen from the atmosphere and then getting it into your next cash crop, right? It's not an immediate thing. It's happening due to biological activity. And understanding a little bit about how that process works is important, because then that helps you better manage that cover crop to maximize the nitrogen you might get out of it. So this is an example of a trial that we did a few years back where we planted, the picture I showed you before, we planted that summer cowpea and pearl millet mixture. So that cover crop is growing in the middle of the summer. And so we know that that plant is taking nitrogen out of the atmosphere, and in its roots, it's converting it into nitrogen that is then being held in the plant and utilized by the plant. And of course, we looked at the roots, and there's those little nodules, the little balls that you can see. So there is now nitrogen inside that cowpea plant, right? And the question is how do we get the nitrogen that we took out of the atmosphere, we put it in the cowpea plant, how do we get that nitrogen now to my next crop, which in this case is going to be broccoli? The way that we have to do that is that we're going to now go in, mow that cover crop before we're ready to plant our broccoli crop, put it into the soil, and that material that's now put into that soil, that chopped up cover crop, is then going to be broken down by microorganisms in the soil. And as those microorganisms start to do that work on that cover crop biomass that's been buried, it's going to start breaking it down into simpler and simpler forms until there are some left over that are now in a form that the plants can take up. And this is the thing I always like to remind people, because if you go out and terminate a cover crop and put it into the soil, we may estimate that there's 40 to 60, maybe even 100 pounds of available nitrogen in that cover crop. But when you mow it and put it into the soil, the next day there's not 40 to 60 to 100 pounds of nitrogen, right? All that material has to go through a biological process and get broken down before it's going to be available in a form that your next cash crop can take up. And so in this case, we terminated our cover crop. We came in, let it sit for about 2 weeks so that it could start to break down. We then laid our beds and planted our broccoli in the fall. And we were able to track that cover crop did actually supply some nitrogen as that material continued to break down and fed our broccoli crop into the fall. But that entire process takes time, and depending on the soil temperature, that's going to be, and soil moisture, that's going to dictate to a large degree how fast that process happens. So in the summer, it's going to happen faster than in the spring or in the fall as the temperatures start to get cooler. But kind of a general rule of thumb is that from when you terminate a cover crop and put it in the soil, the peak of when that nitrogen is going to be available to your next crop is somewhere in the 5 to 6 week range. But of course, depending on how much moisture and temperature you have, that can shift. So you want to try and kind of time that well so that your next cash crop is in the ground kind of within that time frame, so that you're taking advantage of that nitrogen now being available to next cash crop. And this starts to bring up the question of, all right, if I'm going to start growing my own nitrogen, how much nitrogen can I expect from different cover crops? And this is just kind of a general rule of thumb. So you can get anywhere from 50 to, in this case, they estimated all the way up to 200 pounds per acre with vetch. But all of this goes back to how strong of a stand of cover crop do you have? How big is it when you terminate it? And the like. And so if you have a really poor stand where there's a lot of other weeds, the amount of nitrogen you're going to get out of it is going to be much, much less. But if you do a good job of getting your cover crop established, you can get a pretty reliable, part of your nitrogen budget from using cover crops. Because I'm on my strawberry kick today, we've done this in strawberry in several years, and from our summer cover crop mix of cowpea and pearl millet, we can pretty consistently estimate that we're going to get about 50 pounds of nitrogen into our strawberry crop from that summer cover crop. And that's a considerable amount because our pre-plant nitrogen rate is 60 pounds. So we're getting almost our entire amount of pre-plant nitrogen from just using a cover crop. But of course, later in the season, we have to come back and amend additional in season. But you can get a good amount from your cover crop if you have a good stand. And of course, while that cover crop is growing, we know that it's also going to have an impact on reducing the amount of nutrients that may be lost that are already in the soil. Research has shown that reductions in nitrogen, or the amount of losses of nitrogen, to be from 1 to 89%, and reductions in phosphorus losses from 15 to 92% on cover crop ground. And a lot of that work has been done up in Iowa, where there's a lot of concern about bare soils and a lot of our corn ground, and those nutrients being leached off into our river systems that then wind up in the Gulf of Mexico. And so this is, I think, a really important thing for growers to think about, even in the winter, if you have a ground that is going to otherwise sit fallow, of planting a cover crop that is going to help take up some of those nutrients, and then you can return those nutrients back into the soil when you terminate that cover crop. Cover crops can also support beneficial soil microorganisms. We talked about arbusculomycorrhizal fungi, that they can be a host to those. Again, be strategic. Brassicas are not hosts to mycorrhizal fungi. They're kind of uniquely non-hosts, but most of our grasses and legumes are. Cover crops can also provide habitat for beneficial insects, especially if they are flowering, for some of our pollinators, but also things like ladybugs you'll find a lot on clover in the early spring. And then cover crops, of course, the one thing that we really look to them to do is to add organic matter to the soil. And of course, we care about organic matter because it has so many positive impacts on the whole soil system. So from impacting nutrients to helping with soil aggregation, there's impacts across biological, physical, and chemical components of the soil. And there's, of course, research to back that up. A trial, I believe, out of Tennessee found that after 2 years of using reduced till and cover crops in organic vegetable production, there were increases in soil organic matter and soil nitrogen relative to a tilled system that were also using cover crops. However, that they did find that the tilled system had higher weed pressure. I'm not going to dwell on this too much, but I do always like to talk about that, cover crops can be really successful and have a lot of positive impacts on our system, but we have to be careful about how we manage them because they can also become problems in our system if we're not careful. So if your cover crop germination fails and you don't have a good stand and it's too late to reseed, you're not going to get the benefits, right? If your cover crop biomass is weak and it doesn't achieve the weed control that you're hoping for in a no-till system, then you're going to have a backup plan. And this is a picture on the right-hand side where we used some rye, we rolled it down, and it was in a system with very heavy weed pressure. So you see all of that grass that's popping up in through that rolled down cover crop. Do you see the tiny little watermelon transplant in the corner? That's not great, right? That grass is going to quickly outgrow that watermelon transplant. And if your cover crop goes to seed and becomes a weed later in your cash crop, that can also be a problem. And that's one reason why vetch is not a cover crop I generally recommend to people, because it can so quickly go to seed and become a problem later on. And just thinking about how you're going to manage that cover crop, if you're going to use a roller crimper or other types of means and it's not sufficient and your cover crop resprouts, that can also be a problem. And you see a little bit of that happening with our sorghum Sudan that resprouted after we roller crimped it. So I'm going to give just some really quick recommendations based off of our work. We did several trials in watermelon looking at using different winter cover crop mixes in both a no-till system and a strip-till system. And this was inspired by some growers in Northeast Arkansas who were already doing a strip-till system, but they were being sort of they would plant whatever grass was the cheapest cover crop that week, and they weren't being real strategic about choosing what was going to work best for the system. And so we wanted to evaluate some different mixes. But you can see that they have a really nice setup where they're using that cover crop in the row middles to protect those young transplants from being sandblasted by the heavy sand soils. And then they kind of let that roll down later and the watermelon vines can run over it. And so we did a lot of work looking at all kinds of different mixes and individual cover crops. We had 12 different, and we did them in both a strip-till system and also a no-till system and 2 different places in the state. And basically this is what we found. I'm not going to bore you with any bar graphs, you're in luck today. This is our recommendation. Cereal rye, 50 pounds per acre, and Austrian pea, 35 pounds per acre, works great. Works great if you're using no-till system, works great if you're using a strip-till system. And we saw that essentially if you planted it in late September, you got a good biomass and a good amount of nitrogen that would then move into the watermelon crop. What we found was that winter wheat had an effect on suppressing yield no matter what system you put it in. And that was concerning because a lot of our growers were using winter wheat, but I think there's a slight allelopathic effect on suppressing those plants from taking off. So our recommendation is to use cereal rye and Austrian pea. I'll also say we tend to find that mixes work best, whether it's in the summer or in the winter. If in one year it stays really dry and the grasses are going to do better that year, or the next year it stays a little bit wetter and the legumes might do better, by having that mix you kind of hedge your bet about what kind of season it's going to have, and we tend to get better weed suppression and overall stands when we do a mix. I like black oats a lot. It's very low growing and it has good weed suppression, but cereal rye is also a great choice, and I like it a lot because we all get busy and sometimes we get behind in planting our winter cover crops. And cereal rye will germinate even when the soil temperature gets down to around 45. So you can plant it pretty late and it'll still come up. Austrian pea is my favorite legume for the winter. Cowpea is my favorite for the summer. Mustard I think has its place, but it tends to not be very winter hardy, so that's the only thing to keep in mind. And again, my favorite summer cover crop mix is 100 pounds of cowpea and 10 pounds of pearl millet. We found that when we planted it in the summer before fall planting of Acadia broccoli, we got higher yields on the broccoli in the winter harvest. And I realized I have probably overloaded you with just way too much information in a very short period of time. But I'll point you to some other resources if you want to find out more information. These are two great resources that we can get you for free, and we had them at least we have the cover crops profitably in the trade show, so we might still have a few floating around if anyone needs one. It's a great guide on choosing cover crops. And then the crop rotation on organic farms is a great resource. Both of these are free. You can get them online, and we occasionally have printed versions, so just let us know. And if you really like YouTube, we have several YouTube videos. We have a cover crop vegetable production training series, so if you're just doing something in the house and want to have something on in the background, you can turn on our cover crop videos. And we have a whole series there and a couple with growers. And here is my contact information, and that's our YouTube channel there. And hopefully I did okay on time. And I'm happy to take a few questions if anybody has questions.
Have you done any research looking at nitrogen from just a legume versus a legume with grass? Is there any difference in nitrogen?
Yeah, that's a great question. So the question was, and I'll just repeat it so that everyone can hear, amount of nitrogen credits that you might get from planting just a straight legume versus a grass. I think a lot of it is going to go back to how heavy you go with your mix. So we did a trial a few years ago where we kind of did heavy grass with a little bit of legume in it versus straight legume, and then kind of in between of like playing with that seeding rate of what percentage of grass versus legume are you putting out. And I think if you go really heavy grass and there's only a few legumes, yes, you absolutely reduce the amount of nitrogen that you get. If you go kind of the opposite direction where you have, our general recommendation has been that if you're going to do a mix, you take your grass seeding rate and drop it by like 60%, like really cut it down. But keep your legume rate, at maybe only cut it by about 40%. So favor your legume because it's going to have a harder time competing with those grasses. And if you do that and you still have, where your legume is at least 50% or more of the stand that you have out there, you do probably lose a little bit, but you still get a pretty considerable nitrogen credit. And so like that picture I showed you of the pearl millet cowpea, it was a pretty heavy rate of cowpea, 100 pounds per acre is a high rate of cowpea versus only 10 pounds of pearl millet. We were estimating that there was close to like 80 or 90 pounds of total nitrogen in that cover crop, and we would estimate that about 50 to 60 of it was going to be available to that next cash crop. So doing the mix, you just have to be, I think, careful about how heavy you go one or the other. And I do believe there's some research on that, but I would have to go back and refresh myself on exactly how that all shakes out, but that would be my recommendation.
What are your thoughts on adding cover crops in your small berry systems? So like in your blueberry systems or your blackberry systems?
That's a great question. So I think cover crops and berry systems, there's kind of two ways to think about it. So strawberries are an annual crop, so they're more like a vegetable. But for our perennial systems, things like grapes, blueberries, blackberries, the way that I see cover crops working really well for those types of systems is in planting them for a year or so before you go in and plant. So using them as a way to either drive down nematode populations or build the organic matter in the soil. Because once we get into the plants being planted, generally we're going to establish like a grass sod in between the plants that's going to be there perennially. So we don't really do a lot of tillage or management after that. But I do think cover crops work really well for growers in between fruit crops systems to go back to that idea of kind of diversifying your crop rotation. So I would use them kind of as a soil prep before you plant.
What are your thoughts on like planting a perennial cover crop and then terminating that, turn that into a mulch, and then planting the berry stalks in that, and then hopefully keep planting cover crop in that, and so basically the berry stalks would be planting in the cover crop. And so hopefully you would only get the cover crop, and then you would be able to chop and drop and use that as a mulch.
I haven't seen it done a lot except for with a mustard cover crop at the base of a blackberry plant. We have a grower in Northwest Arkansas that was having nematode issues in blackberries in particular, and he did that. He got an Italian mustard and planted it right at the base of his blackberries, and he would let it come up, and then he would chop it with like a weed eater and let it drop, just like you're saying. And he worked with his county agent, and they monitored nematode populations, and they felt like they were having an impact on dropping nematodes doing that. I haven't seen a ton of people do it because the issue is once you have those plants established, you have to be very careful about getting close to the base of the plants with anything that might be a mechanical, so that you're not nicking the canes or the plants. And so it starts to get a little difficult to manage having that cover crop. What I will say is there might be potential for being strategic about what you establish in the row middles. Like for instance, in pecans, we establish clover in the row middles a lot and mow it, and you can get a nitrogen credit from doing that. The problem I see is that a lot of our clovers are also host to nematodes, and so it sort of becomes this battle of, all right, I might get some nitrogen, but I might also be hosting something that is going to ultimately be kind of detrimental to my crop. So, but good question.
On that note, hosting, understand the benefits of brassica cover crops, but have you encountered any challenges with overwintering vegetable brassica pests?
That's a great question. So we didn't talk about kind of the green bridge of overwintering things. Where I have seen it the most is generally not on, unless you're talking about like maybe in a high tunnel system. I have not seen it on mustard as bad because generally our mustard seems to get killed out by like even the temperatures we had a week ago. It usually kills it to the ground and maybe it'll resprout, but that seems to not happen. I will say that we have seen, especially in our watermelon work where we were doing all of the different mixes and individual species of the legumes, we had real concerns that we were creating a green bridge from the winter into the watermelon cover crop, or with the cover crop into the watermelon, because there were aphids galore on some of our leguminous cover crops. And so we were really like, is this going to be a problem? But because we were rolling things down in our no-till system and then letting it sit for a few weeks, and we got a pretty good kill, I think we had enough of a window where the material wasn't green that aphids or whatever was in the cover crop left before we came in with our transplants. But that's a very good question. You do want to be really careful about not using cover crops as a bridge for pests from one crop to the next.
You mentioned your trials, were they based just using fruiting like watermelons and things like that, or did you try any trials for cover crops to follow with vegetables? Or if not, is there a place I can find resources for cover cropping and I want to follow with just vegetables and not fruiting?
Yeah, one of the trials that we did was with broccoli, that we did the cowpea iron clay in the summer and then followed it with broccoli. And I would recommend maybe checking out our YouTube channel because that is specific for vegetables only. And so that entire series is just talking about integrating it into annual vegetable production. All right, well, thank you so much for your attention. It was nice to chat with you all.